In today's lecture, we'll be looking at managing bioinformatics database using MySQL. Let's look at bioinformatics databases. A bioinformatics database is a structured repository that is designed to store, organize, retrieve, and manage biological data. Biological data is so large, so it's important that these data are organized in a proper way so that they can be easily retrieved whenever they are needed. And that is the reason for having bioinformatics database. These databases are important and needed for analyzing and interpreting biological information such as genomic sequences, protein structures, metabolic pathways, or phylogenetic data. So let's look at creating bioinformatics database using MySQL. Creating a MySQL database for biological data generally involves defining tables to store different types of information that are related to biological entities. So we need to define tables just as when we just created an SQL database in our previous lectures. And the table should be able to indicate information on genes, proteins, organisms, and experiments. Creating a bioinformatics database using MySQL involves designing a schema that can store biological data effectively and efficiently. So let's continue. Let's look at creating protein databases using MySQL. Protein databases are a type of biological database that are a collection of information about proteins. So you can create a protein database that contains information about proteins. To create a table called proteins to store information about proteins related to a particular disease, you can see these commands, MySQL commands that are used to create a table called proteins. So just like in our previous lecture when we talked about creating a table, when you create a table that is called proteins, you use the command create, capital create, table. Then the name of the table in this case is proteins. So that is why we have the proteins written like that. The first letter is an uppercase character, while the others are lowercase characters. Then we have the parenthesis that is opened and closed and ends with a semicolon. So inside this table, we have various headings. We have the unit prot ID, that is the ID, and we have the variable character. The variable character in the unit prot ID is 15, meaning that the variable character should not exceed 15. The primary key is also indicated. The protein name is indicated, and the protein name, the variable character should not exceed 255. Then it shouldn't be a null value. That is why we have not null. Then we have the protein sequence heading, which colon, which also indicates the sequence, and it should be a text. It should be text that will be accepted in that column, and it should be not null. Then we have external PDBID. The variable character should not exceed 15, and we have the external PubMed ID, which should be in form of an integer. So that is a command for creating a proteins table. You can go through again. Then if you want to use the insert data command, we can use the insert data command in just as we use it in creating an SQL table using the insert data. Now, we want to use the insert data command just like previously. We type the insert command, insert into. Then the name in this case is proteins. The name is proteins. Then we open the parentheses and close the parentheses with the semicolon. Inside this table, we have the unit prot ID, the unit protein ID, the name of the protein sequence, the external PDB ID, and the external PubMed ID. The values are indicated. You remember when we did the insert data command in MySQL, it's still the same process. So here we have the values. Under the values, we open the parentheses and close it. And within these values, for each of the columns under that table, for unit prots ID, we have the values P1, 2, 3, 4, 5. For protein name, the protein name is example protein. When we have for protein sequence, we have this value MTE, ITAA, MV, KEL, RE, STGHE. That's the protein sequence. Then we have external PDB ID. We have 1XYZ, and we have the external PubMed ID, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's for the first set. We repeat for the second set of values. The unit prot ID is the first within that parenthesis, that is P67890. The second is for the protein name, we have another protein. For the protein sequence, we have MQDRV, KRP, MNA, FI, VW, SRDQ. Then for the external PDB ID, we have 2ABC. For the external PubMed ID, we have 987654321, and eventually close the column. So that is how to insert proteins using MySQL. We can also retrieve data. To retrieve data from the proteins table, you can use the select statement. So if you want to retrieve data from the protein table, just type select asterisk from, then the name of the proteins, that is proteins, and ends with a semicolon. Then we have advanced MySQL operations. There are some operations in MySQL which we term advanced MySQL operations. The first is creating an index. Indexes are used to retrieve data from the database more quickly. For example, you can create an index on the protein name column. Create index IDX_protein_name on proteins in parentheses protein name ended by a semicolon. So when you do that, you have created an index. Then 2, altering tables. you need to add a new column to the proteins table. You can use the alter table statement. So when we want to add a new column to the proteins table, we can use alter table to adjust what we have there. So when we type, use the capital letter or uppercase character, alter table, we have inserted the command. Then proteins is the name of the proteins. Then add column. Then the column we are adding is gene name. Then the variable character is indicated, which shouldn't exceed 255. Then the semicolon closes that command. Then the next is joining tables. If you have another table and you want to perform a join operation, you can do it as follows. Suppose there is another table called diseases. First, let's create a table diseases. So to create a table diseases, just like before, you type the create table command and you put the name. The table name is what? Diseases. Then you open the brackets and close the brackets with the semicolon to end it. So now we put the name of that first column, which is disease ID. One, it should be an integer, int, and the primary key. Then the disease name should also be indicated. The variable character should not exceed 255. Then it should be not null. Then the unit prot ID, which should also be indicated. The variable character should not exceed 15. Then the foreign key, when there is a foreign key for unit prot ID, then we have references, proteins, unit prot ID. Then we close the brackets with a semicolon. So if you now want, so now we have created a table. Now if you want to join that table, if you want to join proteins and diseases table, we already have a proteins table, and this newly created diseases table can be joined to the proteins table. If you want to do that, we just need to type select asterisk from proteins join diseases on proteins.unitprot_id, which is equal to diseases.unitprot_id, closed by a semicolon. When we do this, we have been able to join proteins with the newly created diseases table. Then we have update table. If you want to update existing rows, you can use the update statement, for example, to add a gene name to a row in the proteins table. The update proteins set gene name is equal to gene1, where unit prot ID is equal to P12345. Then we have to delete the data. To delete the rows, we use the delete statement to delete the rows. For example, to delete a protein with a specific unit prot ID, we just type the delete command, delete from proteins, where unit prot ID is equal to P67890, ended by a semicolon. Then we have complex queries. MySQL allows you to perform complex queries to retrieve and manipulate your data. To retrieve specific columns, select unit prot ID, protein name from proteins, where external PubMed ID is greater than 50, that is 50 million, ended by a semicolon. So let's take it again. When we want to perform a complex query to retrieve and manipulate data, to retrieve specific columns, we can type that command again. Select unit prot ID, which is the specific column, protein name from proteins. So it will retrieve that column. Then for step 3, user management and permissions. MySQL allows you to create different users and grant them specific permissions to secure your database. So you can create different users on your database. So let's look at the various commands. Create user. To create a new user, you want to create a new user on your SQL database, you just type create user, open inverted comma, bio_user, open and close inverted comma, at localhost, identified by the password, ended by a semicolon. Then we type to grant permission. To grant permission to a user, we just write grant select insert update on disease database dot asterisk to the name of that user, bio_user at localhost. Once you do that, you have granted permission to the user, bio_user at localhost. Then you want to revoke the permissions. To revoke permission from a user, you type the revoke insert command, comma, update on the disease database, that's the specific database we are using, dot asterisk from the bio_user at localhost. When we do that, we will revoke permissions. The next is performance optimization. The performance of the MySQL server can be optimized by analyzing and optimizing queries and indexing strategy. So, query execution plan. You can analyze the query execution plan using the explain keyword. So, with the explain keyword, you can analyze the query execution plan by typing the command explain select asterisk from proteins, where protein name is equal to open single inverted comma example, then the protein. With that, you can query the plan. Then for profiling, MySQL has a built-in profiler that you can use to analyze the performance of your queries. So if you want to analyze the performance of your queries, you use the built-in MySQL profiler. So by typing this command, set, that's capital SET, profiling is equal to 1. Then select asterisk from proteins, that's the database, where protein name is equal to example protein, ended with a semicolon. Then show profiles, ends with a semicolon. That will show the profiles. Indexing strategy. Based on the query execution plan and profiling results, you can decide which columns need indexing. For example, if you realize that protein name column frequency frequently consider adding an index. Let me explain again. Based on the query execution plan and profiling results, you can decide which column actually needs indexing. For example, if you query the protein name column, if it's a column that you often query frequently, the protein name column, you can consider adding an index. So what simply means is that any column that you often query, any particular column in that table that you always need information from and you always query, then you need to consider putting an index. And to put an index, you just type the command create index idx underscore name, capital on, then proteins. In brackets, you put the protein name closed by a semicolon. Number 5, database maintenance. Database maintenance is necessary to ensure the stability and performance of your system. So if you want your system to be stable, we need to maintain the database. So table maintenance. MySQL provides various table maintenance statements like check table, repair table, and optimize table. So those are table maintenance statements. Check table proteins. So what happens is that when you are using these table maintenance statements, you end it with the name of the table you are trying to maintain. You put the table maintenance statement and the name of the table you are trying to maintain. For example, for the check table maintenance system, you put the name proteins by the side and end with a semicolon because you are trying to maintain the table proteins. Repair table proteins. We are trying to repair the table proteins. Optimize table proteins. We are trying to optimize the table proteins. You also see that all of them end with a semicolon. Then update statistics. MySQL uses stored key distribution statistics when deciding the order in which to join tables. When you are performing a join on something other than a constant, those statistics can be updated using the analyze table statement. So you can always update the statistics by typing analyze table proteins. Step 6, backup and restore. Finally, regularly back up your database to prevent data loss. It's important. If you don't back up your database, you could easily lose everything in your database. So you must try to back up your database as frequent as possible. And you need to know how to restore it if needed. So if anything happens to your database and you need to restore your database, first of all, let's look at backing up the database. To back up the database, we can back up with MySQL dump. For example, type MySQL dump -u root -p disease db greater than disease db underscore backup.sql. With that command, you have backed up the MySQL database. Then you have backed up the disease database, MySQL. If you want to restore that disease database, you just type MySQL -u root -p disease db less than disease db underscore backup.sql. Once you type this command, it will restore what has been backed up. Then number 7 is advanced query techniques. Understanding advanced query techniques can be beneficial in extracting meaningful information from your bioinformatics database effectively. Let's look at subqueries and nested selects. Subqueries allow you to perform operations on the output of another query by typing the command select protein name from proteins, where unit prot in brackets, select unit prot ID from diseases, where disease name is equal to disease 1, close brackets, ends with a semicolon. So we can also group by and have clauses. These clauses are essential for performing complex aggregations and filtrations. So we can see this command, select external pdbid, counts in bracket asterisk from proteins, group by external pdbid, and having counts greater than 1. So with that, we group by and have clauses. That's a way of grouping by and have clauses. This command you have seen here is a command that is used to group by and have clauses. Then we have scripting and automation. Often you would need to automate your database interactions using scripting languages like Python. So we can use scripting languages like Python to interact with to automate our database. For example, we can use Python MySQL connection. When we type the Python code, import mysql.connector. MyDB is equal to mysql.connector.connect, open bracket and close bracket, and you see what you have inside. Host is equal to localhost, user is equal to bio user, password you indicate the password, and database indicates the database. You can also see this command is also a continuation. You can also do data insertion through Python. To do data insertion through Python, to perform SQL insertion in a DNA database using Python, you will need to use the MySQL connector library. Before you begin, make sure you have the library installed. So you need to first of all install the library and continue.